Hello and welcome back. In this brief video, I would like to describe variable component parts within the Perforex workshop program. Uh, Anytime we're modifying something or inputting something, we're going to use the input dropdown. Variable component parts happen to be under subprograms. So I come down to subprograms and I can select variable component parts. Okay, this gives us a full list or a part selection list of everything that's been created in the past. Now we can either use the existing components, we can modify them by double clicking on any one that I want to change, or I could select one by clicking on the left hand side, and then I can press the control key and rename, copy, or delete. In this example, I'd like to go ahead and just take a look at our TS35 by 7.5, which is a Rittal DIN rail. If I double click on it, it shows me some information about this part. We have a graphic on the right-hand side that shows where our punch rows are going to be and all of the data that we input to change our punch rows. To better describe this, I'm going to minimize the screen and show another page that I've developed in AutoCAD. It gives us some descriptions of what each one of these fields will do. Starting at the top, we have a comment on what kind of a part this might be. We can change that to whatever we would like. But below that, we have height in both a positive and a negative. So we describe it as a positive and a negative so that the reference point will be the center of the DIN rail. So in this case, our total height is 35. I divide that by 2 and I come up with 17.5 and negative 17.5. Then to the right of that, we have a couple of columns or a couple of selections here: minimum ultimate spacing and basic grid. Let's talk about basic grid first. Basic grid is very simple. It's the center to center hole pattern of the factory holes. So we just have to measure one hole and find out what our basic grid is. Minimum ultimate spacing is trying to think of how to describe this. It would be if the DIN rail gets cut off before the next drilled or tapped hole, it wants to know where should I go to put the final hole on this for this DIN rail. In my case, I always put a 1 in because it'll back up to the next available factory hole and it'll either drill or tap depending on what you dictate. So I think that's the best way to describe minimum ultimate spacing. All right, so if we come down a little bit further, we see component. In this case, it is actually a DIN rail. So I select DIN rail and I have to enter the raw part length. Now these fields are primarily for the AC18 Secorex machine. We have to enter in how long is the factory part. So when you pull it out of the box, enter in the exact length of what it might be. In this case here, I'm just going to enter 2000. I really don't know what the total length would be. I would have to pull one out of a box and measure it. And if I was working with a cable tray, I would have to put in the distance between the teeth or distance between the fingers. Whatever that distance is, you would enter that in, and it's a center to center of the fingers. Then our final section down at the bottom is where we would enter in the data for our punch rows. And if we look at our graphic on the right-hand side, I can see that the X coordinate will be the measurement of the factory edge to the very first hole, the very first center of the very first factory punched hole. In this case, it's 31. So we can see our X is 31. And by the way, we're doing a variable punch row, which is the only thing that's available to us. The data field is what tool do I want to use. I can double click this and I can change it to whatever tool. If I wanted to do a 5mm tap, I could select tool number 11, double click on it, and it changes my tool to a 5mm tap. So we have our X coordinate. Now for our Y coordinate, we're just going to keep that at 0 because we're going to have all of our tooling punching down the center of the DIN rail. So we're not going to vary on that. Let's talk about screen. When we talk about screen, that is how many holes, how many factory holes am I going to skip to, we could skip 2, 3, 4, 5. In our graphic, I'm showing that we're putting in a drill or a tap at 50mm. So we're skipping one factory punched hole. So 50 would be entered there. I'm going to make the screen larger and show the graphic a bit better. So we can see if I change my screen from 50 and I change it to maybe 150, if you look at the right graphic, if I make that 150 and press enter, it spaces out our drilling pattern. Or I could put 200 in there and spaces it out further. On the far right-hand side, I can zoom in by using the right mouse button, clicking and dragging across it. I can show how the minimum ultimate spacing is working. So if we were skipping, our screen was 200, we would actually miss this hole and the end of the DIN rail would not be fastened down securely. So minimum ultimate spacing tells it to back up to the next available factory hole. Now, if I were to, I'm going to press OK and save this. And I'm going to bring up a 100 by 100 wire tray. Now, in this case, I can see down at the bottom, I have two variable punch rows. Two, because we have a double fastened cable tray. The only thing that would change is that we would add one additional row and everything else stays the same with the exception of our Y. Our Y will now be a negative 25 instead of a positive 25. So Y is from the center line in a positive and a center line to the negative for both rows. Variable component parts are very easy to put together and easy to measure and test and try. So I hope this helps. If you have any questions, feel free to contact me and I'll be glad to assist. Have a great day.